Quick overview of global channel overrides, because Magma is being used in them, and it's important to understand how that works. I'll go back again to my typical scene with the particles moving here, and let's open the Krakatoa user interface and say that we are going to use global overrides. So I'll click on the global button, and I'm now in the global render values options. If I say create a new override set, it creates a new standing object in the scene. It's actually a holder, special holder that we implemented that can accept Magma operators on top. And this holder is being registered with the renderer, and when the renderer is running its particles for the final rendering, it applies the operations on this stack to all the scene particles. So in theory now, if I go and say the color of these particles will be based on the position of the particles, multiplied by 0.01, and that's something that we saw before. You're not going to see any influence in the viewport, and you cannot do anything with the viewport right now because this stuff is run only at render time, and the position is taken in world space. If I also take the absolute value of this and go and render in Krakatoa, I would expect to actually get my particles tinted in those colors. They're actually not very visible in this case, so I'll try to increase the density a little bit, see if we'll see them better. We don't, so I'll multiply by a less strong value, so they will be a lot more colorful. Now you see them. So what we're doing right now is actually taking the position at render time, the position that was already added in the cache of Krakatoa, this position here, and we are running it through a Magma in order to affect the color that the particles will render in. And the cool thing about this is, if I take this PRT loader and hide it and go and enable my particle flow that created that same system and render the same thing, I'm going to get the same result. So it doesn't apply only to PRT objects that Krakatoa ships with, it applies to every single particle system that Krakatoa is able to render. And in this case, this includes also particle flow, thinking particles, pretty much anything that generates particles, all the legacy 3ds Max particle systems, and even vertices if you enable geometry to render as geometry vertices, to render as particles. So the global overrides affect the complete scene. All the particles get loaded into memory and then get processed through those magmas before they get rendered. So it's a good way to affect most of the channels that are relevant to rendering. You cannot affect channels that are not relevant to rendering. So it makes sense to set the color, the emission, the absorption, things like that. You can change positions, obviously, read position and modify it and output this position. If the channel is listed on the list of active channels for rendering, then you can modify it with a global override. So this is what we saw. You can do the same with age and lifespan gradients and pretty much any other control, or you can output to any channel that you want. Custom render elements is the second place where a Magma is used outside of the modifier stack of PRT objects alone. So for example, if I go again into my typical scene and say I open the render elements dialog, I have a bunch of render elements that ship with Krakatoa for the typical things, most of the shading channels, Z depth and velocity and so on. But let's say that your customer asks for a world position render element where the pixel actually contains the floating point numbers, the real positions of the particle in world space. You can create a custom channel and call it world point. And then when you open it and edit it, all you have to do is say Control-O will go into render element. You can change the type of the channel in a render element. It's always color and it always goes to an image. So the only control is whether it will be 16 or 32 bits precision while processing in Magma. And the other thing that you need is Shift P. And the position that will go here is already in world space, so I don't have to do anything about it. The other thing that I have to remember is I shouldn't be filtering, because if I filter, it will be anti-aliased, and it makes no sense for a Z buffer or for word position to be anti-aliased, because it will affect the real-world nature of the data. So in this case, I uncheck the filtering. And the other thing that I have to remember is that when we are in the iterative mode of Krakatoa, render elements don't render. So it's important to actually go switch here to single frame and render a real frame and possibly even save to disk. Because otherwise we won't get what we need. In this case, what we're getting here is if I roll with the mouse and right click, I'm going to get the real world data X, Y, and Z of each particle that was rendered in my color channel. So that's already a very useful render element that we created. We can also change that render element, for example, to create custom velocity render element, or even we can recreate the existing Kryktor velocity, but let's call this vel and modify the content. If I go and change the position here to velocity, what I'm going to output is not really the velocity that the render element would output, because this one is converting it to camera space. And right now we are outputting the world space velocity. So if I render these particles again, I get two render elements, and the one render element, I forgot actually for the velocity again to disable the filtering. It's probably a good idea to do. And if I take a look here, this is the camera space and this is the world space. If I want the world space in my custom version, all I have to do is come here and say, you guy, you're going to be in camera space. That's all I need. Another important thing to remember, I'm going to disable the motion blur for a second. And in this case, if we would look at the Kryktor user interface, which is hidden right now, in the memory channel list, any render element that uses additional channels is going to actually add those channels to the list to be used. If I update here, you see that the velocity is there, even though velocity is not required for motion blur right now, but the render element is asking for it. If I come here and say, you are not going to be enabled, and you will be also disabled, and hit the button here, velocity disappears from the list because no render element is asking for it, and motion blur is also off. So it's very important to remember that if you create a very complicated render element that uses 5 different channels that are normally not used for rendering, they will appear here on the list and will use memory. So your simulation might need more memory to render in Kryktor than you thought. Okay, so we did the word point render elements, we did the velocity render element, the age and lifespan render element. I'm not going to do it, but you can imagine it's pretty much just taking the age and lifespan, convert to floats, divide the one by the other, output the result as a color any way you want, and you can get a black and white gradient, for example. Or you can actually output, let's do it quickly, why not? All I have to remember is to enable this guy so it actually renders. And we can say again, Shift A divided by Shift L. Let's reorder the whole thing, convert this to a float, convert this to a float, and then we'll need to convert this to a vector. So now we have the age divided by lifespan going there, but we can also output the real age as a float and the real lifespan as a float as the green and blue channel. So the red channel will contain the actual ratio, and the other one will be the raw data. Let's see if that worked. If I render now, I would expect this guy here. If I roll over it, the first value, the red channel, contains 0.1, which is the age of the particle. Here is going against 0, and down there, they're getting bigger numbers. And then the second, the green channel, contains the ticks, the number of ticks as a floating point number of the actual age. And the last number in the blue channel is the expected life expectancy, the life expectancy of that particle. So this is a way to pass, for example, to Nuclear Composite or Fusion, an image that contains age data about the particles, even though we don't ship an actual age render element with Kryktor. You can make your own.